From the ocean's depths to the edge of space, science has revealed discoveries that have transformed our view of the universe. Today, we're counting down the top 10 scientific breakthroughs that have redefined our place in the cosmos and sparked revolutionary technologies. Buckle up as we journey through history's most paradigm-shifting moments in science. Our journey into the heart of biology begins with a molecule that is fundamental to all living things, the remarkable DNA. This twisted ladder of life, hidden within the nucleus of every cell, contains the instructions that shape every organism on Earth, from the tiniest bacterium to the largest whale. DNA is not just a molecule, it is the very code that makes life possible, carrying the secrets of our existence across generations. In 1953, two scientists, James Watson and Francis Crick, made a groundbreaking discovery. By revealing the elegant double helix structure of DNA, they showed the world how four simple chemical bases, adenine, thymine, guanine, and cytosine, could be arranged in countless combinations to encode the vast diversity of life. Their work was built on the efforts of many, including Rosalind Franklin, whose X-ray images were crucial to solving the puzzle. This discovery didn't just explain how traits are passed from parents to children. It opened the door to an entirely new field, genetics. Scientists could now understand how DNA replicates, how mutations occur, and how genes are expressed, setting the stage for decades of revolutionary research. Suddenly, we gained the power to trace our ancestry back through generations, diagnose genetic disorders before symptoms appear, and even predict the likelihood of certain diseases. The ability to read and interpret our genetic code has transformed medicine, making personalized treatments and early interventions possible. Today, DNA analysis is at the core of so many fields. In forensics, it helps solve crimes and identify missing persons. In agriculture, it enables the development of crops that are more resilient and nutritious. Anthropologists use ancient DNA to uncover the mysteries of human evolution and migration. The discovery of the double helix was just the beginning. Modern DNA sequencing technologies now allow us to read entire genomes in days, revealing the astonishing complexity and interconnectedness of life. Each new breakthrough brings us closer to understanding diseases, developing cures, and even editing genes to prevent inherited conditions. The story of DNA is a powerful reminder that a single scientific insight can transform our understanding of the world and open up endless possibilities for the future of humanity. Next, we travel to the cosmos, where the very fabric of reality was forever changed by a single mind. The universe, once thought to be a static and predictable stage, was about to be reimagined in ways no one could have anticipated. At the heart of this revolution stood Albert Einstein, whose theory of relativity would transform our understanding of time, space, and gravity. In the early 1900s, Einstein challenged centuries of established thought. With his theories of special and general relativity, he shattered the Newtonian view of an absolute universe, opening the door to a new era of physics. Einstein revealed that the speed of light is not just fast, it's the ultimate speed limit of the cosmos. No matter how quickly you travel, nothing can surpass it. Even more astonishing, he showed that time and space themselves are not fixed, but stretch and contract depending on how fast you move. This means that the faster you move, the slower time passes for you, a phenomenon known as time dilation. Scientists have tested this by flying atomic clocks on airplanes and comparing them to clocks on the ground, confirming Einstein's predictions with remarkable precision. But Einstein didn't stop there. With general relativity, he redefined gravity itself, not as a mysterious force, but as the warping of space-time by mass and energy. Massive objects like stars and planets bend the very fabric of the universe, creating what we feel as gravity. To picture this, imagine a heavy bowling ball placed on a trampoline. The ball curves the surface, and smaller objects roll toward it, not because they're pulled, but because the surface itself is bent. This simple analogy helps us grasp how gravity shapes the motion of planets, stars, and even light. Einstein's theories solved mysteries that had puzzled astronomers for decades. For example, they explained the strange orbit of Mercury, which couldn't be accounted for by Newton's laws alone. He also predicted that massive objects like the Sun would bend the path of starlight passing nearby, a prediction spectacularly confirmed during a solar eclipse in 1919, when astronomers observed stars appearing out of place. These groundbreaking ideas paved the way for our understanding of black holes, the expanding universe, and even the origins of the cosmos in the Big Bang. Einstein's equations became the foundation for modern cosmology and astrophysics. The impact of Einstein's work reaches far beyond physics textbooks. It changed how we see reality itself, revealing a universe that is dynamic, interconnected, and far stranger than we ever imagined. Today, Einstein's legacy continues to inspire scientists and explorers. His revolutionary ideas guide our search for new discoveries as we peer deeper into the cosmos and strive to unlock the mysteries of time and space. Now we dive into the subatomic world, a realm where the very building blocks of reality are governed by forces and particles invisible to the naked eye. Here, scientists have long searched for answers to some of the universe's deepest mysteries, pushing the boundaries of human knowledge and technology. Among the most significant quests in modern physics was the search for the Higgs boson, a particle theorized to exist for decades but never directly observed. Teams of dedicated researchers from around the world collaborated, analyzing mountains of data from high-energy collisions, all in pursuit of this elusive particle. In 2012, after years of anticipation and painstaking experimentation, scientists at the Large Hadron Collider at CERN finally found compelling evidence for the Higgs boson's existence. This discovery was a monumental achievement, the result of global cooperation and cutting-edge technology. The detection of the Higgs boson confirmed the Higgs field theory, a cornerstone of our understanding of how the universe works at its most fundamental level. The Higgs field, an invisible energy field, permeates all of space. The Higgs field gives particles mass. Without it, particles would zip through the cosmos at the speed of light, unable to form atoms, stars, or planets. It's this field that allows matter to clump together, making the universe as we know it possible. Without the Higgs field, the universe would be a vastly different place, devoid of the structures and complexity we see today. Galaxies, stars, and even life itself could not exist. Some particles pass through the Higgs field almost effortlessly, remaining light and nimble, while others interact more strongly, gaining more mass as a result. This interaction explains why different particles have different masses, a question that puzzled physicists for generations. The more a particle interacts with the Higgs field, the heavier it becomes. The discovery of the Higgs boson was the final missing piece of the standard model of particle physics, a framework that describes the fundamental particles and forces that shape our universe. This groundbreaking achievement not only deepened our understanding of the fundamental nature of reality, but also inspired a new generation of scientists to continue exploring the mysteries of the cosmos. In 1928, Alexander Fleming's accidental discovery of penicillin changed medicine forever. He noticed a mold-killing bacteria in a petri dish. This was the birth of antibiotics. Before antibiotics, infections were often fatal. Penicillin turned them into treatable conditions. Antibiotics have saved millions of lives and made modern surgery possible. This breakthrough shows how curiosity and observation can revolutionize health. The era of antibiotics stands as one of humanity's greatest medical achievements. Edwin Hubble's 1920s observations changed our view of the universe. He found that distant galaxies are moving away from us. The farther they are, the faster they recede. This revealed that the universe is expanding, leading to the Big Bang theory. Hubble's work provided the first evidence for a universe with a beginning. The Big Bang model still shapes our understanding of cosmic origins. At the atomic level, quantum mechanics rewrote the rules of reality. Early 20th century physicists discovered that energy comes in discrete packets, quanta. Light behaves as both wave and particles can exist in multiple states until observed. Quantum entanglement links particles across vast distances, defying classical logic. Despite its strangeness, quantum mechanics powers lasers, computers, and medical imaging. Its principles are transforming technology and our understanding of the universe. In the late 1700s, Edward Jenner's work with cowpox led to the first vaccine. He observed that milkmaids exposed to cowpox were immune to smallpox. Jenner's experiment proved that vaccination could prevent deadly diseases. Vaccines train the immune system to fight infections before they strike. Vaccination has eradicated smallpox and curbed countless other diseases. Jenner's discovery laid the foundation for modern immunology. The germ theory of disease revolutionized medicine in the 19th century. Louis Pasteur showed that microorganisms cause fermentation and disease, debunking old myths. Pasteurization and improved hygiene followed, saving lives worldwide. Robert Koch established methods to link specific microbes to diseases. Germ theory led to sanitation, antibiotics, and better public health. Understanding microbes transformed our fight against infectious diseases. Plate tectonics explains Earth's ever-changing surface. The lithosphere is broken into plates that drift atop the mantle, colliding and pulling apart. This movement forms mountains, triggers earthquakes, and shapes continents. Plate tectonics unified geology, explaining Earth's history and the evolution of life. It's a powerful reminder of our planet's dynamic nature. Electricity and magnetism, once thought separate, were unified by James Clerk Maxwell. Maxwell's equations revealed that light is an electromagnetic wave. This insight led to technologies from telegraphs to smartphones. Electromagnetism powers our modern world, from communication to medicine. Maxwell's work is the backbone of today's technological society. From DNA to quantum mechanics, antibiotics to the expanding universe, these discoveries showcase humanity's quest for knowledge. They've reshaped our world and inspired generations to keep exploring. As we look to the future, these triumphs light the way for new breakthroughs. Let me know if you need further tightening or adjustments.